Hey everyone, welcome back to the deep dive. So today, we're going to be diving into a paper that one of you sent in about VTalk. And VTalk is all about visual tokenization, so how AI is basically learning to see the world. But not like we do as like pixels, but as meaningful chunks of information. It's kind of like imagine a translator that can convert those complex images into a language that AI can actually understand and then back again. To help us unpack all of this, we have an AI expert with us today.
Yeah, this is some really interesting stuff. This VTalk system is really quite impressive, and some of the findings were a little bit surprising. It turns out that when it comes to VTalk, bigger isn't always better, especially when we're talking about AI generating new images.
Okay, so that's interesting. So how about we start with the basics? What exactly is visual tokenization?
Well, think of it this way. VTalk takes an image or even a video, and it compresses it into a smaller set of data points, kind of like creating this really efficient summary. These data points are actually floating point numbers, and the total number used is referred to as E in the paper. And the higher the E, the more detail we see in the reconstruction of the image.
So more data points means a clearer image. That kind of makes sense. It's like having more pixels, right? But I'm still a little bit confused about the whole bigger isn't always better thing. Why would having more information make it harder for the AI to be creative?
Well, that is the surprising part. When there's too much E, the AI model can get bogged down. It's almost like it gets overwhelmed with this huge amount of information.
Hmm.
Kind of like if you give an artist like this giant canvas with way too many colors, they might freeze up and not actually create a masterpiece.
Whoa, yeah. Hadn't thought about it that way. So where does that leave us then? If more isn't always better, how do we even find that sweet spot?
Well, that's what the researchers were trying to figure out. They started by looking at two key parts of VTalk, the encoder and the decoder. So the encoder basically compresses the image into those data points we were talking about, and then the decoder takes those points and reconstructs the image. So you can think of it like the encoder translates the image into AI language, and then the decoder takes that language and translates it back into something that we can see.
Okay, I think I'm following. So what happens when you make these parts bigger? Does that make VTalk work better?
Well, this is where things get a little interesting. They found that making the encoder bigger didn't really help at all. It didn't really help with recreating images or generating new ones. It seems like more complex compression doesn't always lead to better results.
So even in the AI world, bigger isn't always better. Interesting. What about the decoder? Does making that bigger help?
Well, they actually found that a bigger decoder did lead to better image reconstruction. It's kind of like having a more skilled artist that can take all those little pieces of information and put them back together in a way that creates a clearer picture.
Okay, that makes sense. But I'm guessing there's a catch, right? We already know that making things bigger isn't always the answer.
You're right, there is a catch. While a bigger decoder was good for recreating those images, it didn't always lead to better AI-generated images. Sometimes it helped, but sometimes it really didn't make that much of a difference. It's really all about striking the right balance.
So it's not just about making VTalk bigger, it's about finding the right size for each of the parts. That's pretty counterintuitive. Why wouldn't a bigger, more complex system always be better?
Well, it really all comes back to that idea of balance. Too little information, and the AI can't create anything detailed.
Hmm.
But too much information, and it kind of gets lost in the complexity. It's about understanding how all those pieces work together to create the most effective system. What's so cool here is that this research is showing that simply throwing more computing power at a problem isn't always the best way to solve it. We really need to focus on understanding how AI actually learns to see and create. And this is where things get really interesting.
I like where this is going. But before we get too far ahead of ourselves, the paper that you sent in also mentioned how VTalk works with video. And videos are like way more complex than a single image. Does this same principle of bigger isn't always better hold true there too? Hashtag TTS, the deep dive episode 2025-0122, part 2 of 3.
It does, yeah, they looked at video. And VTalk was surprisingly good at compressing the data for video, even better than with single images.
Really? That's crazy. Why would video with all of its moving frames need less data than a single image? You'd think it would be the opposite.
Yeah, it does seem a little counterintuitive. But videos actually have a lot of redundancy. When something moves in a video, most of the background and objects stay the same from frame to frame. And VTalk is really good at recognizing this redundancy, which lets it compress the data more efficiently.
So it's finding those repeating patterns and like squeezing them down, kind of like a super efficient zip file for video?
Yeah, that's a great analogy. And here's something even more interesting. The longer the video, the better VTalk was at compressing the data.
Wait, so the longer the video, the smaller the file size? How is that even possible?
It really all comes back to finding those repeating patterns. You can think of a short video like a single sentence, and then a long video would be more like a novel. And there are more recurring themes and ideas in a novel, which makes it easier to summarize and condense the information.
So it's like VTalk is a speed reader for video, getting like the gist of the story without needing to see every single frame. This is like seriously mind-blowing. Earlier you mentioned how the decoder acts like an AI artist, kind of filling in details and making the image look better. Did the researchers go into that a little bit more?
They did. They wanted to understand how the different ways of training VTalk affected the quality of the images that it could produce. It's almost like exploring all the different styles of this AI artist, trying to figure out what makes it create images in a certain way.
So they were basically trying to teach the AI to see differently.
Yes, exactly. It really comes down to the algorithms that are used to train the AI. Imagine like this, you're coaching a soccer player. You can give him different instructions, right? One set of instructions might be like focus on scoring goals, even if you have to be super aggressive. Well, another set of instructions could be play a beautiful passing game, even if you don't score as many goals.
Okay, so like different coaching styles for the AI.
Exactly.
Hmm.
They experimented with different loss functions, which are basically mathematical ways of telling the AI how to measure its own success. So some of these prioritize accuracy above all else, like get as close to the original image as possible. Others really emphasize creating visually appealing images, even if that means changing or leaving out some details.
That's so cool. So they could nudge VTalk toward being like more of an artist rather than just a copy machine.
Exactly. And they found that these different training methods had a huge impact on how well VTalk performed when it was generating totally new images. It's like the AI is taking what it learned from recreating images and using that knowledge to create something totally new.
So what does this mean for you, the listener? What's the big takeaway from this VTalk research?
The key takeaway here is that scaling up visual tokenizers like VTalk isn't just about making them bigger. It's about understanding the connection between all the different parts, the encoder, the decoder, those loss functions we were just talking about,
Yeah.
and really finding the right balance for whatever task you're trying to accomplish.
So it's not about like brute force computation. It's about working smarter, like really understanding how AI learns to see and create.
Exactly. And that's what makes this research so interesting. It's not just about like cool pictures and videos. It's about pushing the boundaries of what's possible with AI. We're really just scratching the surface of this technology.
Now, I got to ask about some of those other variations of VTalk that were mentioned in the paper, like
Right.
the latent variation and the masked variation. What are those all about? Hashtag TTS, the deep dive episode 2025-01-22, part 3 of 3.
Yeah, those variations are pretty interesting. They offer some cool possibilities for like compressing and manipulating visual information. So the latent variation involves adding like a separate set of data points to the original image data. It's kind of like adding this extra layer of information that gives you more flexibility when you're compressing and reconstructing the images.
So it's like giving the AI like a richer language to understand the image.
Yeah, exactly. It allows for more control over the whole process.
Okay, that makes sense. What about the masked variation?
That was pretty cool. So during training, some of the data points are randomly masked or hidden. And this forces the AI to learn how to like fill in those missing pieces of information, which makes it much more adaptable to different types of visual data.
So it's like you're giving the AI a puzzle to solve. It has to figure out the bigger picture, even when some of the pieces are missing. It's learning to be resourceful. I like that.
Exactly. And this technique has actually been used pretty successfully in other AI tasks as well. It helps the AI to be more resilient and adaptable when it has to deal with like unexpected or incomplete information.
Now, before we wrap things up, is there anything else about VTalk that really stood out to you? Anything that you think our listeners should know about?
You know what? One thing that really impressed me was how the researchers were so focused on finding this good balance between like traditional image compression metrics and those generative metrics that we talked about earlier. They showed that by tweaking how they trained VTalk, they could shift its focus. Instead of just creating a perfect pixel for pixel copy, VTalk could generate an image that was visually appealing, even if that meant like sacrificing some of the finer details.
So they were teaching VTalk to be more of an artist and not just a photocopier.
Exactly. And what's really cool is that this shift towards a more artistic approach actually made VTalk better at generating entirely new images.
That's incredible. It shows how much we can do with AI if we think outside the box.
Wow, we've covered a lot of ground today. You've really sent us down a research rabbit hole with this one. And I got to say, I'm way more fascinated by visual tokenization now. But
Mm.
before we go, I want to leave you with something to think about. The researchers experimented with all these different ways to train VTOC, and they really focused on that balance between accuracy and visual appeal. So here's the big question. What if we could control which parts of an image VTOC really focuses on? How would that change things for AI-generated art?
That's a great question, and I think the possibilities are endless. Like, imagine being able to tell VTalk to zoom in on the details of a person's face while making the background simpler. Or to really capture the pattern of a fabric but make everything around it more abstract. It's like a directing an artist's attention, telling them what to focus on and what to kind of ignore.
That's mind-blowing. Instead of
Yeah.
just compressing an entire image evenly, we could tell VTalk to highlight certain elements. The implications for AI art are huge. Absolutely, we could see all these new artistic styles emerge in AI-generated art. All thanks to this ability to fine-tune the level of detail in different parts of an image. And it's not just about art either. Imagine the possibilities for advertising or filmmaking.
Mhm.
You could control what the viewer sees by emphasizing certain product features or highlighting specific actions and emotions in a scene. It's really exciting.
It sounds like AI is going to completely change how we think about creativity. Like, we might even see a merging of human and artificial intelligence. And that could lead to completely new forms of art that we can't even imagine right now.
I think you're right. We're going to see some incredible things happen as we continue developing these AI tools. Who knows what the future holds for art and creativity?
Huge thanks to our listener for sending in this paper. It's given us a lot to think about. And for those of you who want to learn more about VTalk, be sure to check out the show notes. We'll have links to the research paper and some visuals that show VTalk in action. You can see for yourselves the different levels of detail that it can capture and generate. It's really a glimpse into the power of this groundbreaking technology. It's been a blast diving deep into this with you. Until next time, keep sending in those research requests.
And keep on diving deep.